Right now, the wheels of curiosity have begun to blaze the trail for human footprints on Mars.
Well, today on Mars, history was made on Earth. The successful landing of Curiosity will stand as an American point of pride far into the future.
I just want to call and say congratulations to the entire Mars Science Laboratory team and really all of JPL. You guys should be remarkably proud.
So over the past 50 years, we've been pretty busy with respect to Mars. And you may have noticed that some of these scientists are pretty excited. And I'm right there with them because what a lot of people don't realize is that when we're planning a mission to Mars, or anything for that matter, when we're talking about rockets and spacecraft, a lot of these things are people's lives. They spend the better portion of their careers preparing, building, launching, waiting until those craft get to the planet or object that they're studying. And when they succeed or fail, of course, that's the culmination of 15 or 20 years of work and the potential for losing their job if it doesn't work, because they have to have something to do. So, they are very excited because, for the most part, our missions have been successful. We're learning a ton about Mars, and as they highlighted their more recent one, Curiosity rover, which I guess was last year in the summer. Is it 2 years now? It was the summer, I think, 2015. Has been the most successful, I think, other than the Spirit and Opportunity rovers, which were just predecessors of the Curiosity. Mars Science Laboratory, as it's called, or Mars Curiosity rover, is currently on Mars, roving around and doing a ton of science. And one of the things that I think is important to realize is that these rovers have a limited lifetime. So right now, we've got the Curiosity rover, and we also have Spirit. Spirit's the right one, right? Where's Opportunity land? Do you know?
Sorry, I don't remember.
Okay, so there are Spirit and Opportunity, both solar-powered rovers, and I always forget which one is currently active still. But they have an unlimited lifespan because they're solar-powered. Curiosity is nuclear-powered, as a nuclear way that it can drive around. So we know that in like 2017 or so, Curiosity is going to be done. Until then, we're going to keep getting lots of good science from it. So far, it's discovered that not only is Mars wet in the past, that in fact there are some areas that have liquid water now. And some of the spacecraft in orbit have detected water flowing from underground. Now, why is water important? If you were here for last month's or 2 months ago's discussion, water is very important because, not only do we need to drink it, not only do we need it for maybe growing plants. If you've seen, the recent Hollywood movie, The Martian, okay? We also can do many other things with water. Water can be broken apart, hydrogen and oxygen. We can use the oxygen to breathe. We can use hydrogen plus oxygen to make rocket fuel. So the fact that Mars has water, just as it was with our discussion before with asteroids, is key to our ability to do this. if we really want to go to Mars, we need to be able to survive. And that is the key component for life, whether it be life that's, on Earth or elsewhere. I like this infographic. It loads. So this is the NASA Journey to Mars. They made this, and I'm going to use it. So we're starting off kind of way down here, where we are trying to build with our current systems like Hubble Space Telescope, like the International Space Station, using what we currently have to our advantage. Why would you want to be in the International Space Station doing pretty much anything? What's the point of it? Does anyone have an idea? How does this help us to get to Mars?
Getting experience and working the bugs out.
Okay, getting experience, getting the bugs out, right? Okay. And why a space station? Why can't we do that on the ground?
Oh, the Earth, we're out of the Earth's.
Yeah, gravity is a factor. So if you've ever kind of been keeping track of manned missions to space, the Russians have done quite a bit of these long duration missions in the Mir spacecraft, the Mir space station, I should say. We, the US, have not done as much long duration stuff until more recently. We're doing currently a mission that's a 1-year duration. And the idea behind that is we don't know what the effects of long-term space without gravity does to the human body. And we need to understand that to go to Mars. The trip time to Mars is somewhere between, I think, 6 to 9 months to get there, minimum. You kind of time the orbits of the planets, and you shorten it as much as possible. Once again, if you've seen The Martian, you may have seen that is the case. They only have a window, a launch window that they can operate in. And even then, like I said, so up to 9 months to get there. Now, you wouldn't want to just go to Mars and we made it and turn around. That wouldn't be a good use of our trip. So you have to plan on staying there for some duration of time. If it takes you 9 months to get there, you better stay for a little bit more than a few days. Just to give you some perspective. Our lunar missions, how long were they?
On the ground up there.
How long were the total Apollo missions? How long did one mission take, approximately?
8 days,
How long?
about 8 days.
8 days, a week, right? Maybe 10 days, I think, at the most. So we're talking a mission now that's way longer just to get there. Once you get there, you want to spend some time, let's say 6 months to a year, and then you need to be able to get back, and it's another 6 to 9 months. So you're looking at minimum 2 years, probably more like 3. Now, that entire time, you are in a spacecraft. You are, susceptible to the elements. We don't know what that looks like. And even with the ISS, you're right here. The ISS has an escape capsule. If they have a problem on the ISS, get into the escape capsule and come back to Earth. You do not have that option when going to Mars. So we need to understand this. We need to understand how does the human body react, and what are some ways in which we can have technology, computers, help us. Because as we get closer and closer to Mars, we are going to lose touch with our home base. And we're going to need ways to operate. The surgeon that's going to be along, there's going to be a surgeon along. What if you have a health problem? But what if the surgeon has the health problem, right?
Yeah.
Or the engineer, the engineer can't do his job. You need to be a jack of all trades. Everybody needs to know how to do everything, and that includes surgery. That includes engineering. That includes the other stuff they are expected to do once they get there.
And just getting along with each other.
And getting along each other within a closet, basically. You know, this is a challenge. We need to understand that, and NASA is currently trying to figure out how to help people deal with each other. The Space Launch System. We're currently operating the Space Launch System in its early design phase. We are testing the rockets. We're trying to figure out how they operate. Do they operate well? And it's using some of the techniques that we learned through the Space Shuttle program, similar rocket boosters, and similar technologies otherwise from Apollo. Notice they don't look like a space shuttle anymore. They look more like a traditional rocket. That's because they work, and they work well. Orbiters and landers, we're going to continue to do work on the surface of Mars using robots, trying to learn about the surface of Mars, trying to look at where do we want to go, why do we want to go there. It's not like once you're on Mars, you can just jump in, an airplane and fly to the other side of the planet. You probably should get close to where you want to be when you land. And that decision can't be taken back. So once you're there, you're stuck there until you leave. On the other side of things, we've got commercial and crew. So the commercial cargo and crew is what NASA is doing with respect to companies like SpaceX, like Virgin Galactic, like Blue Origin, these commercial companies that are going to take over the low Earth orbit stuff, launching satellites into space, launching crew up to the International Space Station, and you probably have seen a lot of that in the news. The Orion capsule is actually part of this Space Launch System, the very top of the rocket. And this spacecraft was launched last year, and I'm going to show you a quick video in a few minutes. So we know that this works. Once again, looks a lot like what you would have seen during the Apollo era, except for bigger. Not much bigger. We're talking a crew of, I think they've decided to go with 5 people. The traditional Apollo missions were 3. You had 2 people who went down to the surface of the moon, and you had 1 that stayed in the orbiter. That's unlikely. I don't think that you're going to have someone up there for a year plus by themselves. So it looks like this time everybody's going to go to the surface, and honestly, the more the merrier. To some point, you want to have enough people to do your work when you're down there, but 6 is seeming to be a crowd. They were originally talking about 6, but it looks like they've gone down to 5. Oh, and by the way, at any time, if you have questions or things you'd like to add, please feel free to. This is a discussion. Yeah?
Actually, I was going to jump in right there.
Let's do hands, though.
You briefly touched on the idea of flying around. Now, aeronautics on Mars seems to me, with such a minimal atmosphere, that's pretty much impossible.
It does have about 1/100th the thickness of the atmosphere. So yeah, your ability to fly around per se is a lot more limited. I have heard of some people discussing like some sort of balloon type of way of surveying stuff, but no transportation at this point. I think you can get a lot faster just by driving. And they definitely are talking about a Mars rover to be for a person to drive.
With the flaws that you mentioned earlier about the surgeon not being able to perform his duty, would those things make it not possible to put a living creature on the planet?
Well, that's the discussion for tonight, so I want you to decide that after we're done.
The chances, this is just me saying, but I think the chances are 100% that living creatures like us could survive on Mars as long as we have a lot of water, as long as there's a lot of water for the plant for the planet to provide.
Okay, well, I hope you are as excited when I'm done as you are now. All right, and we have,
Well, I was just going to say, on your very last point, that there's an interesting analysis they've done why fives were odd number of people.
hey, a vote can't be I can foresee a point at which things aren't going quite like you had hoped, and there's a vote. Because guess what, NASA doesn't matter, like mission control, who cares what they think, we're here. You know, and I could see that being the case, and if 5 is you can't have an even vote then.
And I don't know, as an offshoot of that, come to think of it, there was a book called The Andromeda Strain, I think, where one of the participants needs to be, I would say, not married or something. So there's a disattachment that the others might have.
Yeah. Things to consider, for sure. So NASA has kind of released their plans to us, and that's kind of where I got this infographic from. And you can actually read this full plan online here, and I've actually done a quick link to it as well in this indented area. This is an awesome document. It's like 36 pages long. I've read the vast majority of it. I'm not going to read it tonight, but I will show it to you. It highlights some of the major hurdles and some of the major waypoints that NASA has identified on our planning stages to get to Mars. So first off, we're going to be starting off with things that are Earth-reliant. Things like the International Space Station, where we are operating with the full support of Earth. We've got mission control. It's all real time, and by real time I mean radio communication. That's, for all purposes, instantaneous. You know, you get on the radio and somebody returns your message almost right away. This is a very easy, very understood way to operate in space. We've been doing it now for many, many years, and it's not that it can't have problems, but the risk is much lower. Proving ground. So in this next stage of operation, NASA is going to do their best to try to prove our technologies in as low risk way as possible. So you're going to see, and already we've started to do some of this with respect to launching the Orion spacecraft. We launched the capsule on top of a rocket that we have been using for years. So we didn't use the Space Launch System, but we wanted to test that capsule to see if it worked. That's pretty low risk, and there was no people inside. Right? They just want to see, does it operate? Does it fly like we think it will? And it was successful. Yes, Alex.
Have they started construction of the unit that's going to move them or take them there yet?
Yes,
They have.
they have. Now, like I said, the capsule, the Orion capsule, is basically the habitat during launch. So we'll get more into that in a second.
Okay.
So once you've proven some technologies, we're going to move on to the stage that is considered to be Earth independent, at which point we'll start to go farther out. We're going to be reaching out farther than we have since Apollo. You know, for the most part, the last 30 years, we've been not really doing much, 40 years. We've not been doing much above low Earth orbit. The space shuttle, I think, was like 300 miles was its range. So, you know, now we're talking going out far again, leaving Earth orbit. Some of the challenges of space pioneers, as we've discussed, you know, having to be so far from home, looking at an 1,100-day mission, major hurdle. And we have to consider how to fund this. You know, we cannot afford to bankrupt the country to do this. It needs to be done in a way that meets a budget, and We're going to be decommissioning the International Space Station at some point. It will have used up its use, and we will decommission it, aka do a burn that causes it to enter the Earth's atmosphere and crash into the ocean. You would rather do that than crash into a city later on. So you decommission it, you shut it down in a place where you know you want to put it. So that is, going to happen at some point prior to 2030. In fact, I think that sometime in the next 10 years, it's planned to do just that. And it also starts to talk about some other things with robotic missions. And something I talked about earlier in the year, which is the Asteroid Redirect Project, Redirect Mission. So we're going to be looking at things like capturing, retrieving, and returning an asteroid to lunar orbit as a way of kind of proving some of this technology, and at the same time getting other information that will be useful for a future space economy, which I would refer you to the YouTube videos to learn more about. We are trying to set up what many people think could be a $1 trillion industry by mining asteroids. And that's up on our YouTube channel. And within here, you'll also see the commercial crew and cargo partners. So companies like SpaceX, which I'll highlight more later. This is the full document that I was talking about. Like I said, I think they did a pretty good job with this. I've read most of it, and it goes into detail with respect to all the things I just discussed. And it seems like they've thought about a lot. And there's good information. There's also good graphics. The graphic I showed you earlier, just a little bit different form of it. So yeah, seems like a natural place. Is there any questions? Yeah.
Would it make more sense to do this while the space station is still in use, that you could take stuff up there and store, put on the rocket to go to Mars?
I think that once I show you the way in which they're planning to do this, that part becomes almost unnecessary. Well, I'll kind of talk about it since you asked. We are going to be using 2 rockets. In fact, I think this might show us here on the infographic. Yeah. So the Space Launch System rockets, notice there's 2 of them. Unlike Apollo, where Apollo, they had one massive rocket, and it had both the crew and their supplies all in one rocket. The idea with this one is, let's use the same basic rocket design to save money, but then add some bigger boosters on the sides of it and change the top out. Instead of an Orion capsule, you put the cargo area. You launch 2 rockets instead of 1. In Earth orbit, you then connect those 2 up, you do docking, and you then travel to Mars from there. That provides you with a huge amount of storage. This rocket is bigger than the Apollo rocket, Saturn V. And then you get the crew separately, which you don't have to just launch one of these. You could launch multiple rockets and 1 crew capsule. So your need for supplies diminishes. To keep something like the International Space Station going longer than it really should be will cost way, way more money than launching a few more rockets. So I like what you're thinking, but I think this way kind of circumvents maybe some, what if something failed in the ISS and now we're stuck? This kind of fixes that problem.
So I guess then my question a minute ago is answered. The idea of going up there and recycling stuff off the space station is kind of out of question. It's just not.
I don't think it's part of their game plan now. All right, so the Orion spacecraft. Let's take a look. So, once again, I really hope that you use these links here and do a little bit more digging on your own. Here is our maiden voyage of Orion, as I said, on a rocket that we've been using for a number of years. There's a little thing here about showing us the Space Launch System. This is a kind of virtual animation of that that you can kind of watch a little video of. And here we have a short video about the progress towards the Orion exploration. So I'm going to share it with you. So as you can see, it is under construction. So something kind of noteworthy, I think, with that video was you may have seen them landing on the land rather than water. That's one distinct difference, I think, between the Apollo missions and the way we watched those. And people came back and landed in the water, in the oceans. We're now trying to land on the land. I think it's a choice. I don't think there's any real major difference between them. It's just kind of interesting that they chose to do that. So any questions about what you saw there?
Well, Mars doesn't have any oceans.
No, I'm saying here on Earth.
Oh, is that capsule will land on Mars too, and then come back?
I don't believe that's the game plan. There's a lander similar to what we did when we went to the moon.
Oh.
Yeah, in the Apollo missions, the orbiter was a separate thing than the lander, and the orbiter was then the return capsule. I would expect it to be similar to that. All right. There was a test flight, as I said. I think for time's sake, I'm going to skip that. All the links are here. And I just wanted to kind of highlight there are different parts of this one website that kind of walk us through that same, those same waypoints that NASA had pointed out in that document. So we have the Orion spacecraft, the actual Space Launch System, which is the rocket. We've got ground systems that help us to kind of stay in connection with NASA, plus the launch facilities. Those are currently being worked on right now at Kennedy Space Center. We've got the Asteroid Redirect mission, which is going to help us to prepare and kind of get our space legs, if you will, and allow us to kind of test this in a less risky environment, but still higher than low Earth orbit. And then the robotic missions at the International Space Station. So within these, each of them has its own separate web page. I'm not going to get into too much detail with that, but once again, each of them has a lot of information for you. I do want to highlight the commercial crew aspects of this. So we are going to rely with NASA-trained astronauts flying aboard what's called the Dragon spacecraft. It appears to be, at least. That's going to be the way we go. The Dragon spacecraft is SpaceX, a company's crew capsule. And they have already proven themselves to have the ability to dock this spacecraft. It's already in operation. At this point, all it's doing is supplying the International Space Station with supplies. And in the future, the game plan is to take out the cargo area and put in seats. And we'll be once again having people go up from the launch pads at Kennedy to the International Space Station.